welcome to thedeciphers.org. My name is Cortelia Kataria and I am a 9-year-old computing explorer and problem solver. I got a 9 on my GCSEs just last year when I was 8 and right now I'm doing my A-levels.
I'm Isaac. I'm an experienced maths teacher working with the Deciphers.org to help deliver some revision sessions. So what are we working on today, Cortelia?
So today we're going to be doing an A-level mathematics session and it's actually the same one as we did last time. We're just doing the last half of the questions. So October 2021.
Good, yeah, last time we got up to question 6, so we're going to be starting on question 7 today and seeing how far we can get.
Yeah.
So, are we ready to start?
Yeah, just putting my calculator a bit off the way. And, yeah.
Good, so question 7 says the circle C has equation x squared plus y squared minus 10x plus 4y plus 11 equals 0. And part A wants us to find the coordinates at the centre of the circle C and the exact radius given our answer as a simplified third.
So the line L has equation, and for part B, the line L has equation y is 3x plus k, where k is a constant. And given that L is tangent to C, find the possible values of k, giving your answers as simplified thirds. So, what we could do is, for part AI, we could complete the square. That would change x squared plus y squared minus 10x plus 4y plus 11 into x minus 5 squared minus 25 and then plus y plus 2 squared and minus 4, and then finally the last one is plus 11, and so if we add them all up,
And what does that equal? So that equals 0 on that line. 0 on that line.
One second. One second. The score just turned off for a bit. Okay, there we go.
Back on there?
Yep. And then that's equal to plus 2 squared. And then minus 25 minus 4 is minus 29, and minus 29 plus 11 is equal to negative 18. So that minus 18 equals 0.
Good, well done. Remember, if you have any questions in the chat, feel free to add them in as we go along, or if you want to suggest a different way to solve these problems, then always just pop something in the chat.
Yeah, so then x minus 5 squared plus y plus 2 squared equals to 18.
Good, so now we've got it in that form, what can we do? How do we then find the centre and the radius?
So the centre is just when the x and minus 5 cancel out and the y and plus 2 cancel out. And that's when x equals 5 and y is minus 2. So when this equation equals 0, not 18. So, 5.
Yeah.
For part II, the radius is just square root 18 because if we look at the equation, that's r squared, wrong part. If we look at the equation of the circle by comparing the things, 18.
Yeah, so we don't remember that. If you can't remember the equation of a circle is x minus a squared y minus b squared equals r squared, where the centre is AB and the radius is r.
So r is root 18, and that is, so 18 is 2 times 9, and 9 is square root of, 9 is basically 3 squared, so then square root of 3 squared is just 3, so it's 3 root 2.
Perfect, well done. So, part B, we're then told that the line y equals 3x plus k is a constant. We're told that that is a tangent to C. We want to find possible values of k.
Yeah. So, all we have to do is to just sub it in to the equation. Then we'll get x minus 5 squared plus 3x plus k plus 2 squared, and that equals 18. X squared minus 10x plus 25
Good.
plus 9x squared. So 9x squared plus 2 times 3x times k plus 2, that's 6kx plus 12x. And that equals 18.
What about the k plus 2 times k plus 2?
So the k plus 2 times k plus 2, that's k squared plus 4k plus 4. And we'll just add it on there to make. That's k plus 4k plus 4.
Good, yeah, so expand all those brackets out. So you have x squared minus 10x plus 25 for the first bracket, and 9x squared plus 6kx plus, 6kx plus 12x plus k squared plus 4k plus 4 equals 18, that's right.
Yep. So then what we can do is just find the determinant. It's b squared minus 4ac, so we should move on to the next page. Nice, and then it's so this shows
You mean the determinant?
then b squared minus 4ac, says that.
So we're going to use that. It's not called the determinant. What is it called? Close.
The discriminant.
Discriminant, yeah. Determinant is to do with matrices. Yeah, you're right, the discriminant.
I always mix up those.
What might we want to do before we get it into, before we can use that, we might want to change the quadratic a little bit.
Yeah, we can do change it to we can change that to x squared to x squared and 9x squared, that's 10. And then minus 10x plus 6kx plus 12x plus then that is 2 plus 6k times x, and then finally k squared plus 4k plus 4 plus 25 is
29 it should be. Oh, 4 plus 25, yeah, sorry, 25.
So it's 4k plus 29 is 4 plus 25.
What does that equal?
That's 18.
Good, so what should it be equal if we're going to use the discriminant?
Not sure.
So whenever we're using the discriminant, it's solving a quadratic, but the quadratic must be equal to
0.
0, so we need to take that 18 from both sides. So let me just write the quadratic out so on the next page so we can see it. So we've got 10x squared plus, and you're spot on, 2 plus 6k. That's that x terms if we factorise the x out from there. And then we've got plus k squared plus 4k. And then we're taking away the 18 from the 29. That's plus 11. That equals 0.
Then what we can do is do the determinant is
Discriminant.
discriminant is b squared minus 4ac is 2 plus 6k squared minus 40 times k squared plus 4k plus 11, and that equals to, it says that find the, I think it should be more than 0 because there's more than one possible solution.
So what you've done is you've substituted the line into the circle equation, okay, and you've turned that into a quadratic, and made that quadratic equal to 0. Then you use the discriminant. You're saying that the discriminant has to be greater than 0 because it has more than one solution.
Yeah.
Is that what you're saying?
Yeah.
But if it has more than one solution, then that would mean the line intersects the circle how many times?
Twice.
Twice, yeah. And if it intersects it twice, is it a tangent?
No.
Now, how many times should it intersect it?
Just once.
Once. So what should the discriminant equal?
Should
Equal 0, 0, or 0?
just 0.
Yeah, it should equal 0. So because we're told our line is a tangent to the circle, we know that the solution to the simultaneous equation has exactly one solution. So that's why we set our discriminant equal to 0. Yeah, well done.
So if we expand that out, we get squared minus we get so we get this expression that
Good.
0.
Good.
And then if we collect the like terms, we get so 24 minus 160 is minus 136.
Fine.
Right. So then, and 4 minus 440 is negative 436. That is
Negative 436, good. Minus 136k, remember?
oh yeah. And then what we can do is just wait. Is it divisible by 4? Yeah, they're all divisible by 4. Like negative 4 too.
Yeah, negative 4 would be a good idea.
And then 136 divided by 4 is 34.
That's that.
And then 436 divided by 4 is 109. So then, if we
So we've got k squared plus 34k plus 109 equals 0. And because it's asking us, if you remember in the question, it's saying give your answer an exact, or give your answer simplified thirds. The best way to go from here because would be to
complete the square. So k plus 17 squared.
complete the square. We could also just put it in our calculators, remember, but complete the square. It's always good practice to complete the square.
Yeah. So then minus 289. And plus 109 equals 0. So that minus 1 minus 180 equals 0. K plus 17 squared equals 180. K plus 17 equals the square root of 180. And that is the same as 6 root 5 because it's 36.5. Okay, it's plus or minus.
Good, well done, good spot.
It's negative 17 plus or minus 6 root 5.
Excellent. That is correct. Well done. Okay, should we move on to question 8?
Yeah. Wait, 1 second. There, I got there.
Yeah, so a scientist is studying the growth of two different populations of bacteria. The number of bacteria N in the first population is modelled by the equation N equals AE to the KT, where T is greater than or equal to 0, where A and K are positive constants and T is the time in hours from the start of the study. Given that there are 1,000 bacteria in this population at the start of the study, it took exactly 5 hours from the start of the study for this population to double. Part A is asking us to find a complete equation for the model, and part B is saying hence find the rate of increase in the number of bacteria in this population exactly 8 hours from the start of the study. Give your answer to two significant figures. So let's do part A and B first before we look at the next bit.
Yeah. So then, if they were 1,000 at the start, then that's where T is 0. So A times by e to the power of K times by 0 is 1,000, and e to the power of anything times 0 is just e to the power of 0, which is just 1. So A is 1,000. And another way you can show that A is 1,000 is that you can say that A is just the initial. A is the initial. A is always the initial population. That's 1,000.
Good, yeah. So when it's AE to the power of something, then A is always that initial population. Obviously, it would change if we had a plus something on the end. But in this case, yeah, A is always the initial population, so 1,000. So we've got A is 1,000, well done.
And it took exactly 5 hours for the population to double. So 1,000 times e to the power of 5k. Now that is 2 times 1,000, which is 2,000. So e to the power of 5k is 2. 5k is ln 2.
Good.
K is ln 2 divided by 5.
Good. Probably in this case, it's probably best to write a fifth of ln 2 rather than a fraction, because a whole fraction like that.
Okay.
Just look a little bit neater when we then put it into the power.
And what we want to find out is the population in 8 hours.
So first of all, you haven't written your answer to part A yet.
Yeah.
Find a complete equation for the model.
1,000 e to the power k, t ln 2.
Good. That's what n equals, yeah? Make sure it's asking for the complete equation, so n equals 1,000 e to the power of a fifth ln 2 t, or a fifth t ln 2, as of course it is written there.
Actually, one time in Dr. Frost's maths, I was answering a question that was like similar to this one, where we had to write a complete equation, and I wrote only the right part, and I got it wrong.
So make sure you're reading that question carefully, otherwise you might get deducted a mark in an exam if it's asking for a complete equation and you don't write an equation, because an equation has to have an equal sign.
Yeah. And otherwise it's just I forgot what you call it, but
Just an expression.
Yeah. And just sub in 8.
So are you saying to part B just sub in 8?
Yeah. 40.
Okay. Are you sure the question's asking for the rate of increase in the number of bacteria in this population at exactly 8 hours from the start of the study?
So what we have to do
If you
is
sub
find
in
the derivative. So D.
We have to find the derivative. Good. Yeah, if you substitute 8 straight into that, you're finding the number of bacteria, not the rate of increase in the number of bacteria.
So 1,000 times a fifth ln2 is 200 ln2.
Good, yeah.
And times by e to the power of 50 ln2.
Good.
And now we just sub in T for 8.
Good. That's right, well done.
T that's 200 ln2 e to the power of 2. That is 202 and by 200 ln2 times e to the power of 8. So I'm doing calculation, and it's 420.25 approximately. I'll just round that to 420.
Yeah, it's asking for 2 significant figures, I think. Right. Yeah, good answer. 2 significant figures. So yeah, 420. Spot on.
Then part C.
Okay, part C, yeah. So it says that the number of bacteria M in a second population is modelled by the equation M equals 500 e to the 1.4 kt, where k has the value found in part A and t is the time in hours from the start of the study. So it's the same k. Given that t hours after the study, capital T, after the study, the number of bacteria in the 2 different populations was the same. Find the value of t. So find the time in which the 2 populations are the same.
Yeah. So then what we can do.
Let me write down the 2 equations so you don't have to keep scrolling up. So we've got n equals 1000 e to the 5th ln2 t, and m equals 500 e to the 1.4. But our k is the same, so our k was a 5th ln2 t. So there you go, there are your 2 equations.
Yeah. So then it says that find t where t is, they're the same. So 1000 e to the power of a 5th ln2 times t equals, and it's a capital T. 500 e to the power of 1.4 5th ln2 times t. And if we divide by 500, you get 2e to the power of fifth ln 2t
Good.
equals to e to the power of 1.4 times the fifth ln 2 times t. And then that's just, we just do the ln of, so ln of 2 times something is the same as ln of 2 plus ln of that something. And actually, because it's e to the power, they cancel out to make 1/5 ln 2 t. And that's the same as 1.4 times a fifth ln 2 t.
Good, so you're taking ln of both sides, fantastic.
And then we can just divide by ln 2. Yeah. 1 plus a fifth, 1 plus t and 5 equals to 1.4 t. And then if we multiply by 5, we get 5 plus t equals to 7t. So 5 is 6t. T is 5 over 6.
Okay, you've made a mistake somewhere. Let's see where you made a mistake. So, what did you do? So you took ln of both sides. Okay, so that'll be ln2 plus ln of e to the fifth ln2, which is just a fifth ln2t. And, okay, that looks right. So there's something not quite right here, because checking the answers, and you can check your answers right by putting it back into the original equation, and you won't get that they're equal to one another. Can you see? Check your answer by putting it back into the original equation.
So 1,000 times by e to the power of 1/5 times 5 6 is 5 and 30 ln 2 that's 1122.462048 500 times by e to the power of 1.4 times 5 and 30 and then 2.
I can see where you've gone wrong, Cordelia. I can see I've spotted it. On the right, so you've got going up to this line here. Okay, you can see you've got ln2 plus a fifth ln2t, and on the right you've got 1.4 a fifth ln2t, and the next step you divide through by ln2. Yeah?
Yeah.
So this step is fine up to here. Yeah, up to the one I've just ticked. But when you divide through by ln2, you'll get 1 plus g over 5.
Yeah.
That's fine. But what should you have on the right hand side?
5.
Good, yeah. You've left that fifth out.
Yeah. So that actually should be 5 plus t is 1.40.
Good, yeah. So it shouldn't be 6t, it should be...
So it should be 0.4t. So t is 5 and 0.4, which is 12.5.
That is correct. Good, yeah. So it just shows the importance of going back, substituting your answers back in to spot mistakes.
Yeah. We've been streaming for 37 minutes. So question 9.
Okay, question 9. We've got a function 50x squared plus 38x plus 9 over 5x plus 2 squared 1 minus 2x, where x does not equal minus 2/5 and x does not equal a half. Why not?
It's because when you sub in those two, then it's just 0. The denominator is 0.
Good, so that function will be undefined there. Given that f of x can be expressed in the form a over 5x plus 2 plus b over 5x plus 2 squared plus c over 1 minus 2x, where a, b and c are constants, find the value of b and the value of c and show that a equals 0.
So what you can do is it's just partial fractions. So let's just make the denominators the same. Right. So multiplying. Let's multiply the a divided by 5x plus 2 term by 5x plus 2 times 1 minus 2x.
Good.
Plus b times 1 minus 2x divided by 5x plus 2 squared times 1 minus 2x plus 5x plus 2 squared, c times that, divided by
Good.
5x 2 squared times 1 minus 2x.
Good. Yeah, so essentially we're adding those fractions together, finding that common denominator, timesing through by what's needed to get that common denominator. Good. And that should give us a nice identity we should be able to then use to find the values of a, b and c. So what identity would that give us?
So, we know that that's 50x squared plus 38x plus 9. We can just multiply by 5x plus 2 squared times 1 minus 2x. So b times 1 minus 2x.
So yeah, so I'm just going to write that out for you. So we've got a 5x plus 2, 1 minus 2x, just so we can get it all on one line. B 1 minus 2x plus c, just copying what you're writing down, 5x plus 2 squared, and that is identical to the numerator of our original function, yeah? So 50x squared plus 38x plus 9.
One second, it's just not working. The rubber's just not working.
It's okay. It's working on mine, you're deleting what I've written. Does it come out?
No.
Yeah. Just a bit of a delay between what I've written, between my one note and your one note, isn't there? But
I think we should stop streaming for a bit. There we go. So then we can sub in x is minus 2 and 5.
just
And then, so what I'll do is make, actually no, not minus 2 and 5, because I'll make both C, actually yeah, because I'll make both C and A that go to 0, so it's only B. That's now.
good, yeah. Good strategy. X equals negative 2/5, so substitute. Make sure you're showing, the examiner what you're substituting in, so I'd write down let x equal minus 2/5. And you can do the substitution on your calculator. Like you said, you know that the A term will go to 0 and the C term will also go to 0, so just substitute it into the 1 minus 2x.
1 minus, that's 0.2. B times 0.2.
So you said in minus 2/5?
Yep.
Because I think it's going to be bigger than 1.
Oh yeah.
If it's one take away a negative number.
So it's 1.8.
1.8, that's right.
And that's 50 times by minus 2/5.
With these questions as well, if you know how to, a really good thing to do is to use the store button on your calculator to store all values for x, and then you can type in the expression. So you can type in 50x squared plus 38x plus 9, and then, because you're going to use it again for other parts of the question, then you can just use the arrow keys to go back to the expression after you've changed the value to for x, and it just saves a bit of time. So really, like using the store value and storing values for x is a good little tip if you know how to do that. If not, then just substitute those numbers in.
And you can also use the calc button on your calculator. It's just right now x is 0, so we can just change it to something. We want -2 first right now, so -2 in 5, and it'll give the answer.
There you go.
And whenever we want to sub in a different value, just press calc again and then type in the value.
Yeah, you press X first, then you press X and then calc.
Yeah. And just divide by 1.8. B is 1.
B is 1, spot on.
And then what is it? So find the value of B and the value of C. So C, and then we'll just, so if we sub in a half, then that'll make B and A go to 0.
Excellent, yeah, that's what we want to do. Let x equal a half.
And we get C times A. 5 times, so 5 squared, wait, no, 2, okay, now that's squared, and half. That's 20.25.
Yeah. The 81/4 probably might be a bit easier. You could leave it as a decimal, but it tends to be, fractions tend to be a bit better.
And that's 40.5. So all we
Good.
and if we divide by 20.25, we get C is 2. Then we have to show that A is 0.
Yeah, good. So C is 2, yeah, excellent, and we want to show that A equals 0. So part B, part II. So there's lots of different ways we can go about this. What way are you going to suggest, Claudia?
You just subbing in the values of B and C that we have already, and then just or maybe we could just sub in a random value like x is 0.
Brilliant. No, I think that's better. I think if you substitute the value of A and B equals what you found, and then you could equate coefficients, and that's a good way of doing it. But if you just let x equal 0, so many terms cancel out nicely. It becomes a lot simpler. So I think that's the best way of doing it. Yeah. So let's let x equal 0.
Because in the quadratic, it's just that plus 9 you're left with.
Yeah, on the right hand side. What do we get on the left hand side?
On the left hand side, it's just remove all the terms with, just remove all the things with x in, so plus 2, and so it's 2a.
Good.
And then 1 minus 2x just goes to 1. So plus b, that's 1.
Yeah, so 2a plus b, which we know is 1, yeah.
Plus b plus c times plus 4c, so that's 8.
Good.
And then that is 9. So 2a plus 9 is 9.
Excellent.
So 2a equals 0. A
Good.
So
A must be 0. Good. Well then, I would say though, again, because that showed that question, and you did start writing 2a plus b, but then you did change the b to 1. I would just make sure you leave that line of working out in actually. So 2a plus b plus 4c equals 9. Is it quite an important bit of your working out in that question? Because it is a show that question. Okay. Part B. So again, 2 parts to part B. Well, 7 marks in total, so quite a bit of working out here. Using binomial expansions to show that in ascending powers of x, our original function f of x is p plus qx plus rx squared plus ... where p, q and r are simplified fractions to be found. We also want to find the values of x for which this expansion is valid. So if I write the expression down for you, so you don't have to keep scrolling up. So f of x, we use our partial fractions from what we've done in part A, plus then we had 2 over 1 minus 2x. There we go. So that's what we found in part A. So now we need to find the binomial expansion of that.
That's the same as 5x plus 2 power of minus 2 plus 1 minus 2x power of minus 1.
Good.
And if we split it up, then let's find the binomial expansion for this. It's 1 plus, then it's and 1 plus, and then the power times x, and by the x term.
Okay, so this is one of the formulas in the formula book, so you can always refer to that. But I'm going to say that because you have made a really, really common error with this binomial expansion. You're sort of on the right track, but we can only use the binomial expansion formula or binomial theorem for negative and fractional powers when it is what was the binomial in the form of.
Must be x plus c to power of something.
Not necessarily x plus c, because that's sort of like this term, isn't it? That we've sort of got. And it works with, if it's x plus c to the power of an actual number, sort of the binomial theorem that you learned in AS in year 12, that you can do that. But for the A2 stuff, with the negative and fractional powers, we can only use the binomial expansion for negative and fractional indices when it's 1 plus ax or 1 plus nx. Yeah, so because of that, because it's 5x plus 2, we need to do something so that it's 1 plus something.
So we can bring out the 2 to the power of minus 2, and
Excellent.
that's a quarter. So 1 plus minus 2 times 5 into x plus minus 2 times minus 3 over 2 factorial, times by 5 into x squared
Good.
5 into x squared. Because we also want to raise the 5 into.
Sorry. Yeah, well remembered.
And that's and a quarter times like that. So P is a quarter because a quarter times 1 is a quarter. And if we expand it out, negative 4, so quarter.
Remember, P might not be a quarter because we've still got the other expression to expand as well.
It's quarter minus 5 in 4x plus 3 times 3 times 25 and 4, which is just 75 and 4.
Good, so 3 times by a quarter.
So it's in 16 x squared. And if we expand this one, it's already in the form that we want. So.
Okay, good, but look at the fraction quickly because you've missed something out. It's not just 4 minus 2x to the minus 1.
It's 2 times that.
Yeah, good.
And that's 2 times. Okay, so 1 plus nx and the x term. Minus 1 times 2x.
Good. So I'm going to be using that same formula again. It's in the formula book if you want to look it up, but of course it is using now for binomial expansion of negative indices. So you have 1 plus nx plus n times n minus 1 over 2 factorial x squared. But in this case our x is actually negative 2x, so it isn't exactly right keeping it in brackets, so we're not mixing up double negatives and stuff.
So it's 2 plus 4 plus 4x.
Yeah, good. So you multiply that 2 times out as well, so that's where the 4x comes from. Plus 8x squared. Brilliant. Yeah, so I'm just going to write that down as well. So we've got it together. So 2, 1 minus 2x to the negative 1 is 2 plus 4x plus 8x squared. Good. So those are the 2 expansions for each of the partial fractions that we worked out in part A. So we can then work out f of x.
Just trying to. The rubber's not working again.
No, do you need the rubber?
Yeah, because of this black thingy. Let's just continue. Right.
Yeah, just put it underneath it.
So,
Yeah, it's coming up on mine, I'll rub it out for you.
so if we add them together, then we get 2 1/4. It's 11 plus 11 and 4x. 203 and 16.
Brilliant.
Excellent.
Fantastic, yeah. Well done. So that's our final expansion for f of x.
And r is 203 and 16.
You think q11 over 4, you've got 11 over 4 now, so it looks like you've got 14 over 4 for q. Okay. Okay. So then the next part says find the range of values for x for which this expansion is valid.
So what we need to do is just all we need to do is to just do it's just when and for this one it's negative, wait, abs off. This one it's absolute of x. This one negative 2/5. And this one is abs off x is less than negative halfway, positive half.
Can the absolute value of x can the absolute value of x ever be less than negative 2/5 or less than negative half?
Can't. I mean, less than positive 2/5. So, and 2/5 is less than a half. So it's the most restrictive condition. So it's that one.
Yeah, so modulus of x has to be less than 2/5. So let's just remind people who are watching the rule. So if we are expanding 1 plus nx to the power of negative, let's not use n there, x to the 1 plus ax to the power of n, where n is negative, or even if it's a fractional index as well, then essentially we want each of our terms in our binomial expansion to go to 0. So our higher power of x needs to go to 0. So that's going to happen when the modulus of ax is less than 1. So that's what Courtney has done for each of these two questions. He set the modulus of 5 over 2x less than 1 to give the modulus of x is less than 2/5, and the modulus of 2x is less than 1 to give the modulus of x is less than a half. So that's how he's got his answers.
I guess it's been an hour and 10 minutes, so I think we should stop now.
Yep, that sounds good. And then we've got how many more questions have we got to do? Question 10, 11,
12, 13 and 14.
12, 13 and 14. Okay, hopefully we can get through those in the next session. We might have to do it over another couple of sessions. Hopefully you found this useful. We're going through the questions quite detailed, so that's why it's taken us a bit longer than the 2 hours that you get in an exam.
Thank you.
Revision session.